Howdy, y'all. So 9.6, like I said, solving equations. So y'all, we will start out doing exponential equations, and then at the end we'll do logarithmic equations. So we're going to start out solving exponential equations. And y'all remember, exponential equations will come in this form: y equals a to the x. Now remember, a is the base, and x is our exponent. So we'll be basically solving for the variable as it's an exponent, okay? So the steps to solving. So y'all, this first step is, if it can be done, makes it a lot easier. So if it's possible, rewrite each side of the equation using the same base. Okay, because we got a little property that we call the base exponent property. And this base exponent property says if a to the x equals a to the y, so if the bases match, then x equals y. So if you got the bases matching, then that means the exponents have to be equal to each other, okay? So that's a big property if we can get this rewritten. Now, it might not be possible to rewrite each side using the same base. So we use another method to solve it. So if not possible to rewrite each side using the same base, so what we got to do is do something that we can bring this exponent down so that we can solve for it. So if we can't rewrite each side using the same base, then we're going to do another method. We're going to take the log or the ln of both sides, then using the power rule, so y'all, we did the power rule yesterday. Power rule was where I had the exponents and I brought them down in front of the log and wrote it as a product. So I'm going to use the power rule. I'm going to bring the exponents down. And rewrite as a product. So y'all, that's using this property we did. Log A of B to the C equaled C times log A of B. So that's my power rule. Remember, all we did was drop that exponent out front and rewrote it as a product. But doing that brings the exponent down like I need it. All right, y'all. So at this point, no matter which step you did, you either rewrote it as the same base or you took a ln and log and brought it down as a product. At that point, solve for the variable, and then, like any equation, check answers if needed. Okay, so plug your answer back in, see if you get what you needed, okay? All right, y'all, so let's solve some equations, exponential, okay? So these examples are just going to say solve for x. So our first one, I got 6 to the x equals 36. So y'all, the question you got to ask yourself, can I rewrite this 36 using a base of 6? And for this one, I can, because if you start multiplying out 6 times 6 is 36. So I can rewrite 36 as 6 squared. So on this one, I'm going to rewrite 36 as 6 squared. So that's going to give me 6 to the x equals 6 squared. All right, y'all, so that's a trick, trying to rewrite your number as this base, okay? So my bases match now. So let me write that. So my bases match, so using the base exponent property, that means that the x has to equal to 2 because those are my exponents. And you're on this one, there's nothing else to do. So x is 2. So if you put a 2 in for the x, 6 squared, 6 times 6 actually equals 36. Okay, y'all? Let's try this one. 4 to the 3x equals 256. So, y'all, the question is, can we rewrite 256 with a base of 4? And so, y'all, I'll show you a trick I do. Um, I can go to that calculator and let's just start multiplying. 4 times 4 is 16 times 4 equals 64 times 4 equals 256. And y'all, that's what I needed, 256. So I had 1, 2, 3, 4 fours. So that means I can rewrite 256 as 4 to the 4th power. All right, so let's bring that down then. I got 4 to the 3x equals 4 to the 4th. So y'all, once again, I was happy because I got my bases to match. So since our bases match using the base exponent property, that means that this 3x has to equal that 4. So unlike this one actually has to go a little further to get that solved for x. Since we're multiplying 3 times x, we need to divide both sides by 3 to make that a 1x. So I'll have 3x divided by 3 equals 4 divided by 3. So that cancels, giving me 1x, and that's going to equal 4/3. So if you put the 4/3 in here, the 3's cancel, and you'll have 4 to the 4th power, which is 256. All right, y'all, on those rewriting the bases, are y'all good on that, or y'all have any questions? All right, y'all not seeing nothing, so let's move on. Let's do one where you can't rewrite them using the same base. How about 5x equals 19? So, y'all, I cannot rewrite 19 using a base of 5 because 5 to the first is 5. 5 squared is 25. So I can't get a 19 out of multiplying that 5. So I cannot rewrite each side using the same base. So since we can't rewrite each side using the same base, I'm going to take a log of both sides. Okay, so I'm going to have the log of 5 to the x equals the log of 19. All right, y'all, so let's see. At this point, once we took the log of both sides, I said we're going to invoke the power rule and bring those exponents down. Well, the only exponent we're worried about is the x. So what we need to do now is take that x, bring it down to the front, and write this side as a product of x times log 5. That's going to equal the log 19. Now, y'all remember, although this says log 5, this is really a number. So anytime we had a number by the x, if we wanted to get the x by itself, we divided by that number. So what we want to do on this one is divide both sides by log 5. That'll give me my x by itself, okay? So you're going to bring down x log 5. You're going to divide by log 5. That's going to equal this log 19 divided by log 5. Now, when you do this problem, they're going to give you an opening parenthesis on your calculator. So just make sure you close that parenthesis around each of your logs. So in the calculator, it'll throw these parentheses up on you, okay? So those will cancel, giving me my x. And let's see, that's going to equal. Now, since we're doing logs, this is going to give us a decimal answer. They want me to round it 4 decimal places when you got decimal answers. So y'all, there's only one way to do this, and that's on our calculator. So I'm going to clear everything off. Now, I always make mine look like a fraction by hitting the alpha y equals and enter. All right, so on top I had a log of 19. On bottom, I had a log of 5. Now, y'all, I want you to show you something. Y'all watch this answer. I'm going to round it off 4 decimal places. I get 1.829. All right, the 4 has an 8 after it, so I'll round the 4 up to a 5. But y'all, I'm going to show you something. I'm going to do this problem again, but I'm going to use the ln this time. ln 19, close parentheses, and then on bottom, ln 5, close parentheses. I just want y'all to see this. No matter which log you use, the natural log or the common log, you're going to get the same answer, okay? That's why I said in the beginning that you can take a log or a ln of both sides, okay? Now, we'll say when I deal with the E, remember Euler's number, the E, when I deal with that, I will use the natural log on it, okay? Now, you also remember, if you can't rewrite the base, you're going to round them decimals out, okay? Now, the also number 4 here has 4 to the 5x minus 5 equals 256. So my first question would be, can I rewrite each side of this using the same base? And y'all, we know we can on that because we had 256 up here and we was able to write it as 4 to the fourth. So that means I got a base 4 here. I can definitely rewrite this, okay? So once again, I'm going to rewrite 256 as 4 to the fourth power. So the left side, I got my 4 to the 5x minus 5. That's going to equal 4 to the fourth power. So we're happy now, right? We got the same bases. So my bases match. And y'all, since the bases match, that means the exponents are equal. So 5x minus 5 has to equal 4. All right, so now we just have a issue that we just got to solve that for that x. All right, so to solve this one for x, we're going to what? Add 5 and then divide by that 5. So let me add 5 first. That's going to give me my 5x. That cancels. That's going to equal 9. And then let's make the x into a 1 by dividing both sides by 5. So that divides out, giving me 1x. Y'all, I can't do nothing to the 9/5. So I'll leave that as a 9/5. So y'all, that's the first thing I look at on these is, can I rewrite it using the same base or do I need to do the log stuff to it, okay? So let's do another one with logs. 3 to the x equals 2. Alrighty, y'all, so there's no way I can rewrite 2 using a base of 3. So I cannot rewrite this one. So I'm going to go up here like I did here, and I'm going to take a log of both sides. And y'all, it's really important on an equation that whatever you do to one side, you got to do that to the other side, okay? All right, so we're taking a log of both sides. That's going to give me a log of 3 to the x equals a log of 2. Now, y'all, so guess what? Using that power rule, we're now going to bring that x down to the front. So I'm going to get an x times log 3 equals a log 2. Alrighty. So now I want to isolate my x. I'm going to divide both sides by log 3. You know, them logs cancel, giving me a 1x. Once again, since I'm taking logs, I'm going to round this out 4 decimal places and use my calculator. So alpha y equals enter. On top we had what, a log 2. On bottom, I had a log 3. All right, y'all, so hit enter. So going out 4 places, that'll be a 0.63. Let's see, I got a 0, but it's a 9 after it. Oh, but that's going to stay a 9 because after the 9 is a 2. So we'll go 6309. So y'all, these equations really aren't that bad. It's just getting that starting step of, am I rewriting them or am I taking the logs, okay? So let me show you one where I would really use the ln. I've got e to the t equals 543. All righty. I'm not even going to attempt to rewrite 543 using the base of an e. No way I can do that. So, but y'all, since this has the e for the base, I'm going to take a ln of both sides. So I'm going to have the ln of e to the t equals the ln of 543. So y'all, this is going to simplify a little quicker than the other ones. Um, Remember, ln is really a log base e. So this is really a log base e of e to the t. So this whole left side, remember, we had that property yesterday. We had a property that says log base a of a to the b. If that log base matches the base raised to an exponent, this whole thing equaled the exponent. Well, that's what I got going on here. A log base e of e to the t. This whole side is only going to equal the t. So to finish this out, all I got to do on this problem is take the ln of 543. So y'all, let's go knock out the ln of 543. So there's my ln. Put in my 543 and enter. All right, so I got 6 point, let's see what we got, 297. The 1 has a 0 after it, so I'll leave that a 1. And that'll be 6.2971. All right, y'all, so that's your exponential. Any questions on those? And just remember, when you're doing exponential, if you got e involved, take an ln. Any other thing, I just take a log. Um, so they're not bad. You just got to play with them a little bit. And I don't see no questions, y'all. So let's move on and do some logarithmic. So we're going to be solving logarithmic equations. So those will come in the form of y equals log a of x. So now my variable is in the result section of the log. Because remember, there's my base, that's my result. So, steps to solving. First thing you got to do, if needed, combine logs on either side. So y'all, what I mean, if I got more than one log on one side of the equals, I'm going to combine them using those properties from yesterday. If they're being added, I'll write them as a product. If they're being subtracted, I'll write them as a quotient. Okay? So I want to write each side as a single log. So at this point, um, while ago I had a base exponent property. Well, now I got logarithmic equality. So what I mean by that, do we have a log base equal to a log base? So I got a log base on one side equal to a log base on the other side. If so, then logarithmic equality applies. Logarithmic equality tells me if I got a log base a m equal to a log base a n. So I got the same base logs on either side. Then that means if the bases are the same, m has to equal n. Right? The results got to be the same if they're equal and they got the same base. All righty. If we do not have a log base equal to a log base, then rewrite as exponential. And y'all, we've done that the other day. Remember, exponential was when I had log base a of x equaled y, if and only with a to the y equaled x. Okay, so we rewrote these the other day. I think the other day I had the y here and the x here, but it don't matter. You can see that the x is still the result, y is still the exponent, a is still the base. So rewrite it as exponential. At that point, no matter which way you went, solve for the variable. Now, y'all check this out. You got to check these if needed. Well, the thing you got to remember on this one is you cannot take a log of a negative number. So we throw away any solutions that produce a log of a negative number. Okay, y'all, because it's not possible to take a log of a negative number. Remember, we got those do not exist type answers on those. Okay. So the first thing I'm looking at, can I combine logs on either side? At that point, I'm looking like a log base equal log base. I can use the logarithmic equality. If not, I'm going to rewrite them as exponential and then solve for that variable. So y'all, let's get started on solving logarithmic equations. And these are going to say solve for x again. All right, should be on number 7, I think. All right, so I got log base 2 of x equals 3. So they're going to start out mellow here. I've only got one log on this side, so I cannot combine logs on either side. I don't have a log base equal to a log base because I don't even have a log on the right side. So since I got a single log equal a number, all I can do, y'all, is go down and rewrite this one as exponential. So rewrite it as exponential. Your base is 2. Your exponent is 3. And that's going to equal the result of an x. So y'all, all we got to do is figure out what 2 to the third power is. So that's going to be what? 2 times 2 times 2. So I get 8 equal to my x. So if you can get them into exponential, they can start going pretty quick for you, okay? Now, y'all, so one similar to that would be this one. Log base 4 of 4x minus 9 equals 4. So y'all, looks like once again, I don't have any logs to combine on both sides because I got a single log here, no log here. I don't have a log base equal a log base. So y'all, I'm going to do the same thing I did here and rewrite this thing as exponential. So my base is 4. My exponent is 4. And 4 to the 4th is going to equal that result of a 4x minus 9. So y'all, the biggest thing in this first few problems is being able to rewrite these things as exponential, okay? All right, so let's figure out, 4 to the 4th. Ooh, we know that by now. We've did 4 to the 4th was what we rewrote a certain number as a while ago. So 4 times 4 times 4 times 4, remember, was 256. That's going to equal 4x minus 9. Righty, y'all. So what we're going to do, add 9, divide by 4. All right, y'all. So what's that? 256 and 9 is what? 265 equal to my 4x. And I'm trying to see, let me see how they want these answers. And so they're just writing them as decimals on these. So 265 divided by 4 will equal my 4x divided by 4. All right, y'all. So let's see. 265 divided by 4 equals 66.25. That'll equal our x. All righty, so I guess they only want you to type fractions if they tell you to type fractions on them. So most of these looks like they're only using decimal answers, okay? All right, y'all, so a single log equal to a number, I rewrote them as exponential. So let's move it on up now. I got a log x plus a log x plus 15 equals 2. So a log x plus a log of x plus, that's a 15 there, is going to equal 2. So y'all, this one, I got 2 logs on the left side. So my first step was combine logs on either side if needed. So right here, we're going to combine logs. We're going to write as a single log. So these are being added. So remember, when they're being added, we write it as a product. X times x plus 15. All of this will equal 2. Now, y'all, I'm even going to go one more step and multiply this out. So I'm going to bring down my log. X times x is x squared. And then x times 15 is 15x. All of this equal to 2. All right, so it's back to this point. I've got a log equal to a number. I've got a log equal to a number. I'm going to rewrite as exponential. So most of these, unless you got a log on one side equal to a log on the other, you're going to have to rewrite these as exponential, okay? But y'all, I need a little help here. I don't have a base here. So what's the base we said when there's not a base down here by that log? What would y'all use? All right, Livy, we're going to use a 10. Good job. So 10 is the base. Exponent is 2. And 10 squared is going to equal the x squared plus 15x. All right, y'all. So the first thing is I'm going to figure out what 10 times 10 is, and that is 100. Notice up here, all you had was x's. Yo, that's an x squared. Since that's an x squared, I need a 0 over here equal to my polynomial. So to get a 0 over here, we're going to come in and subtract 100 from both sides. So y'all look at that. I get 0 equals x squared plus 15x minus 100. All right, y'all, so we're going to have to do a little factoring. X squared is an x and an x. The last number is negative, so one will be positive, one will be negative. So y'all, that's a negative. So what I need is factors of 100 that'll subtract and give me 15. So what will multiply to get a 100, but subtract to get us a 15? So 1 and 100 ain't working. 2 and 50, that ain't working. So 3 don't go. 4 and 25, that ain't working. What's next? 5 and 20. Oh, y'all, I can stop because 5 and 20 will subtract and give me that 15. Now remember, the larger number will be positive like the middle. So the 20 is positive and the 5 is negative. All right, now we're factored. Let's set both of them equal to 0. Now, y'all, if you want to, remember, you could do the quadratic formula to get these answers. Use a 1, positive 15, negative 100 for your A, B, and C. And you'll get the answers doing that also, okay? All right, y'all, so here I'm going to subtract 20. X equals a negative 20. Here I'm going to add 5 and get x equals a positive 5. So y'all, the question of the day, what's the final answer to this problem number 9? What are we putting in MathLab? Oh, so let me show y'all. I got a negative answer. I got a positive answer. Over here, I said, uh-oh, cannot take logs of negative numbers. So we throw away any solutions that produce a log of a negative number. Well, y'all, if y'all put that negative 20 in for that x, you're taking the log of a negative 20, which we cannot do. So we gotta throw away that negative answer. So can't keep the negative answer. So in MathLab, you're going to put a 5, and that's the only answer you're putting on that one, okay? Hey, also be careful for that. Most of these, when you factor them, they're going to give you a positive answer and a negative answer, so just be careful, okay? All right, that was what, number 9? All right, so we're on number 10. Oh, y'all, let's watch this one. They got a log base 5 of a t plus 14 minus a log base 5 of t plus 6 is going to equal a log base 5 of a t. So over here on the left side, we got 2 logs. We're going to write this left side as a single log. Now remember, these ones are being subtracted. So since they're being subtracted, this will look like a quotient. Positive factor on top, the factor being subtracted on bottom. So bring out your log 5. We'll have a t plus 14 on top over a t plus 6. That's going to equal the right side, which is a log base 5 of a t. But y'all, we're happy on this one. I got a log base equal a log base. So on this one, the log bases match on each side. So remember that logarithmic equality told me if the log bases match, then this equals this. T plus 14 over t plus 6 equals t. Now this kind of equation is something we'll be doing in the support later. But all these kind of equations, I make it look like a fraction, equal a fraction. So since the t don't look like a fraction, if you want it to look like a fraction, put a 1 under it. Because when I got a fraction equal to a fraction, what I do to solve that, I cross multiply. Top times bottom will equal top times bottom, okay? So, that's what cross multiplying is. So, 1 times t is t 1 times 14 is 14. That's going to equal the other side when I multiply both of these by the t. Now remember, you got to distribute that t to both of these. So t times t is a t squared. T times 6 is a 6t. Okay? Just remember, when you cross multiply, the single thing has to multiply by both of these, okay? Oh, y'all look at that. It's got a t squared in it. That means I need a 0 over here and everything on this side. So I'm going to start out, I'm going to subtract t from both sides. And I'm going to subtract 14 from both sides. Now I'm just putting the 14 out here because it would go where the number was. The t's line up and then my t squared, okay? So that cancels, that cancels. The left side ain't nothing but a big 0. So bring down your t squared. Then you're just adding like terms. Well, 6t and a negative t give you a 5t. And then there's no number up here to worry about. So just bring down your negative 14. So look here. We got something to factor. So t squared would be a t and a t. Last one's negative, so you're going to have unlike signs. Okay, y'all, give me some factors of 14 that'll subtract and give me a positive 5. So 2 and 7, good job. So 7's bigger, it'll be positive like the middle, and then my 2. All right, y'all, so set both your factors equal to 0. And solve. So here I'm going to subtract 7. Here I'm going to add 2. All right, y'all, so what's your final answer? T equals 2, good job. We're going to throw away that negative answer again, okay? All right, y'all, looks like break time again. So let me stop my share. I'm going to pause this. All right, y'all, so number 11. All right, y'all, so number 11, we got a log 5 of x plus a log 5, x minus 1, equals a log 5 of 6. Oh, y'all, hang on just 1 second. All righty, so the first thing on here, we got 2 logs on the left side. We need to write that as a single log. So notice this time they're being added, so we'll write it as a product. So we'll bring down our log 5, and we'll have x times x minus 1. All that'll equal log 5 of 6. And y'all, I'm going to go like while go and just multiply this out real quick. So I get a log 5. X times x is x squared. X times negative 1 is a negative x. All equal to log 5 of 6. So now look here, we got a log base equal to a log base. So that means this result equals that result. So x squared minus x is going to equal 6. Alrighty, so quadratic again, so we need a 0 over here. So I'm going to subtract 6 from both sides. And I get an x squared minus x minus 6 will all be equal to R0. Alrighty, y'all, so this one's going to have to be factored again. So x squared is an x and an x. Y'all, once again, that's negative at the end. So we're going to have unlike signs. All right, y'all, so let's find factors of 6 that'll subtract and give me 1. So we only got 2 guesses on that. So it's not 1 and 6. It'll be 2 and 3. So 3 is the larger number, will be negative like the middle, and the 2 will be positive. So y'all look, we're factored. So we need to set each of these factors equal to 0 again. So y'all, the first one, we'll subtract 2. I get x is negative 2. The second one, we'll add 3. And get x is a positive 3. But y'all remember, cannot keep a negative number because I cannot take a log base 5 of a negative 2. So we're throwing out that negative answer, and the only answer is positive 3. Y'all, here's the last one. So these, not too bad. You just got to start out, do I combine logs or not, and then move on, okay? All right, so this last one, we got a log base 3, x plus 12, plus a log 3, x minus 12. Y'all, let me write this on another page. All righty, so log 3, x plus 12, plus log 3, x minus 12 equals 4. All righty, so this what? This one has 2 logs on the left side. So we will write the left side as a single log. Now they're being added, so this will be a product. It'll be the x plus 12 times the x minus 12, all equal to the 4. And y'all, once again, I'm going to multiply these. But remember, these are conjugate pairs. Anytime I got conjugate pairs, when I multiply, I'm going to do the shortcut. So bring down that log 3. So to shortcut this, x times x is x squared. 12 times negative 12 is a negative 144. All that equal to 4. Now y'all remember, anytime you got conjugate pairs like this, you can shortcut these because your inner term, the 12x, the outer term, negative 12x, they're always going to cancel, okay? All right, y'all, I got a log equal to a number. So remember, anytime we had a log equal to a number, we write as exponential. So my base is 3. Exponent is 4. And that's going to equal the x squared minus 144. All right, y'all, so let's figure out what 3 to the 4th power is. That's going to be 3 times 3 times 3 times 3, which is like 9 times 9, which would be 81, equal to x squared minus 144. Y'all, there's two ways you can solve this. Since it's an x squared and just numbers, you can add 144 to both sides and do square roots. Or you can subtract 81 from both sides and factor it. So I've been doing a lot of the square roots in the past. So let me do one where we actually factor it. So I'm going to get a 0 on this side. That's going to give me 0 equals x squared, negative 144, negative 81, give me a negative 225. All right, so we're going to put these in parentheses. X squared is an x and an x. The last number is negative, so you'll have unlike signs. Now remember, since there's not an x here, it's like a 0x in the middle. So you're looking for factors of 225 that'll subtract and give you 0. But y'all, since this is perfect squares, to get that number, what's the square root of 225? So y'all find me the square root of 225, and that's what we'll put in both of those parentheses. That ought to be 15 and 15. So 15 times 15 equals 225. 15 and negative 15 give me 0 like the middle, okay? All right, y'all, set both of them equal to 0 and solve. Now, if you did the square root stuff, you'd have had a 225 equals x squared. Square root of 225 would have been a plus or minus 15, okay? So either way to solve that, so this one will give us a negative 15. This one will give me a positive 15. But y'all, if I put that negative 15 up here, negative 15 and 12 give me negative 3. I cannot take a log of a negative. So once again, we got to throw away our negative answer. So y'all, that was 9.6. So I'll play a little bit with the support. Okay, so in the support, they give you a few problems to get you used to doing that cross multiplying. So these will say solve. So number 1, x minus 7 over x plus 1 equals 1/2. All right, so remember, I said to cross multiply these. So the x minus 7 times 2, you got to multiply 2 by both of those. So 2 times x is 2x. 2 times that negative 7 is a negative 14. That'll equal the right side when we cross multiply. 1 times x is x. 1 times 1 is 1. Now just solve this. So since my x's are bigger over here, I'm going to subtract the smaller x from both sides. So 2x minus x leaves me an x minus 14. equal to 1. And then I'll add 14 to both sides and get x is a 15. So y'all really, the first three problems, that's all you're doing. You're cross multiplying. So let me go to number 4. R squared minus 9r minus 10 equals 0. So this one was just one to get you used to factoring. So this one practiced on the cross multiplying. This one's practiced on factoring. So r squared is r and an r. Last number's negative again, so one's positive, one's negative. And y'all, what I need is the factors of 10 that'll subtract and give me 9. And that'll be what, 10 and 1. So 10's larger, it'll be negative like the middle. And then your 1 would be positive. And then at that point, set both sides equal to 0 and solve. All right, so my first one, let me subtract 1 from both sides. Second one, let me add 10 to both sides and get a 10. All right, y'all, 5 you didn't really get hit with in this section. But it's another factoring one. 3n squared plus 13n plus 10 equals 0. Now, a lot of times I use the quadratic formula when I got a number in the front. But y'all, I'm going to show you how to do this one by factor by grouping. Okay? So for this one, what you got to do first is multiply the first number times the last. So 3 times 10 equals 30. So watch what I do. I'm going to rewrite the middle using factors of 30 that add to get 13. So y'all find me some factors of 30 that'll add to equal 13. So we got 1 and 30, so 10 and 3 will work. So y'all, what we're going to do is rewrite the middle using 10 and 3. So we got 3n squared plus 10n plus 3n plus 10 equals 0. So do y'all remember the other day we did the factor by grouping? I grouped the first two terms together and the second two terms together. I'm going to factor out the greatest common factor from each group. So y'all, the first one, the numbers don't have nothing in common, but I got an n squared and an n. So we're going to factor out an n. In parentheses will be a 3n plus 10. Now, the second GCF is positive like the third term here. Since it's positive, the second GCF is positive. And y'all, 3n and 10, what's the only factor you can factor out of that? So a 1. So that's going to be a 1. And then basically you're dividing 3n and 10 by 1, so you get a 3n plus 10. All right, so remember, my parentheses matched, so I bring that down as one factor. The other factor is the n plus 1 on the outside. All that equal to 0. All right, y'all, so let's set both of these equal to 0 and solve. So you can either do this method or, like I said, A, B, and C, do that quadratic formula, okay? So what are we doing? Subtracting 10, then divide by 3. So 3n is a negative 10. Divide by 3. Looks like n will equal a negative 10 thirds. On the second one, all I got to do is subtract 1 and get n is a negative 1. So these problems, we're just going back to get you really sharp on your factoring. 1, 2, and 3 are doing the cross multiplying stuff, okay? Alrighty, y'all. So the question is, any questions? All right, y'all. So let me show you what's happening next week. Monday, we do 9-7. It's a really short section. Tuesday, we're going to do Module 4 test review. Wednesday, we're going to study for the final exam review. And then Thursday will be final exam day. Okay, so I'll probably go on and open that final exam probably on Wednesday so that if y'all review that day and you want to go on and knock it out Wednesday, you can. Otherwise, it'll be due at midnight on Thursday. All right, y'all. So after midnight on Thursday, you will no longer have access to the math lab. So get caught up on everything you can this weekend so that Monday we can knock out 9-7, and then Tuesday review for test 4, and then Wednesday that final exam. All right, y'all. So I'm gonna stop my share.